So Manish's question is, every time we want to view the video online, do we have to enter our names or email addresses? Um, I think so, yes. But there is no restriction on how many times you can do that. So um, I know it's an additional step, but other than that, really there are no other side effects to that. Anyway, so today is day 2, and we are still working our way through um, the software development lifecycle models. And today's main topic is we are going to cover the V model. Now, V model is not in any way different from the waterfall model, except in the way it is represented. So we'll talk about what V model is, and we'll try to talk about all the different phases of testing and all that today. So that is where we will spend the majority of our time. Verification versus validation, QA versus QC, quality and defect, these are few words that we will try and define in the class today. Now, understanding the difference between verification and validation is one of the very basic concepts that QAs are expected to know. And as I told yesterday, we are going to refer to the software testing team constantly as quality assurance team. Now, why do we do that? That is something that we will try and analyze and understand. So QA stands for quality assurance, and on the contrary, QC stands for quality control. So quality control is, to put it simply, is just testing itself. So what is the difference between simple testing and the quality assurance that we claim to be doing as software testers? So that's something that we will try and understand today. So the way in which we will proceed with the class is we will try and first we will define the words quality and defect, and then we'll move to the V model. And in the process of understanding V model, the verification versus validation is an inbuilt aspect of it. So we are going to cover both of them in one go. And at the end of the session, we will take the QA versus QC concept, because that is not really connected with any of the other things we are doing today. So we'll do that topic at the very end, and then I'll take all your questions. And I got all your assignments, and I must say this is the highest turnaround rate that I've had. So very well done, and thank you. And the quality of the assignments are also really good. But I mentioned in all your, as I mentioned in all your emails, this is just to orient us. See, so far we've been software's users. So it takes a little bit of orientation to look at a software as a solution for a problem and look at its constituent elements. And that is the first step to being successful as a tester. So that is why, we did that assignment, and that's the exact tone of the assignments that we are going to keep for this week. Now, what I mean by tone is we'll try to keep it non-technical. We will not include words like what are we writing, whether are the requirements, scenarios, test cases. So we'll not get technical. We'll do it in a common plain English like stuff. And then starting next week, in fact, I was thinking tomorrow itself I'll introduce you all to the live project. So over the weekend you can do some exploration on it and, get to familiarize with it. And so that from next week onwards, when we get to the, much more technical assignments, you'll all be able to use the application and, start working on it right away. So that's the plan basically. And some of you have let me know that the pace of the class and the content of the class is understandable and is working for you. Thank you for that. And if anybody has any questions, if you feel like I'm going too fast, or if you have anything that you want me to repeat, please let me know in the chat window, and we can make sure that this class is beneficial to each and every one of you. So with that, we'll get started with what the definition of quality is. So let's start with a little bit of interaction here. Now, thank you, Padma. So Padma says a certain standard to abide by. Yes, that is the perfect formal definition for it. But let's look at it from the more usage standpoint. So what I'm trying to tell you is, let's say you're trying to buy a product, and that product is maybe an electronics product like a cell phone or a camera or something like that. So what do you think? I mean, we all want to buy quality products, correct? Nobody wants to buy a product that is inferior, especially in the quality area. So when we are, making a decision to buy a product, what do you think that we look for? I mean, what would each one of you look for when you're buying a phone or a camera? So all suggestions are welcome here. Okay, I'll start the list. Clarity, thank you. Something that will give great pics. The memory is a yes. So when we are talking about things like focus, vendor reputation, that's a good one. So when we are talking about vendor reputation, so why do we look for vendor reputation? So is the product reliable or not? Is the people, are the people who are building this product, are they reliable or not? Yeah, that's a good one. Then again, pixels, clarity, does it take good pics or not? So all of what we are trying to see here is, does the camera work the way it should work? That's number one. And then there is user friendliness. Absolutely great point as well. And would we not look at the cost, team? Do you think if it is really good, but it really costs like an astronomical amount, do you think anybody's going to buy it? No. So there's also the aspect of money and how much we are paying and all of that stuff. So if you look here, each one of us came out with different definitions of quality. For us, if you need to buy a product, if for us to certify a product to be a quality product, for some it is coming from a reliable source like vendor reputation. For some of us it is the ease of use. For some of us it is the efficiency. Is if the camera is supposed to take good pictures, is it taking those good pictures or not? And for others it is whether or not it's being economical. And then the other factors, like, is the size playing a role? Is it portable? Is it too heavy? Is it, all of those other factors are also coming into picture. So what we have to try and understand here is that quality does not mean the same thing for everyone. So according to the formal definition that Padma has given us, it says that a certain standard that it needs to abide by. But are we coming with a common standard for everybody in this case? We are not able to come up with a common standard here. So how do we solve that problem as QA teams? Because we are the quality assurance team, which means it is our responsibility as software testers to ensure that the product has an assurable quality. But how do we measure quality? How do we know how to, say whether or not a certain product adheres to quality standards? Now let's step back here and take an objective look at who are the stakeholders in the entire QA process. We have the client, as we discussed yesterday, and we have the producers, or people who are building the software, and then there are customers. So when you actually break down your broad spectrum of users, you can actually channel them into these three areas. So there's clients. For the client, what do you think is the definition for quality? It should be something that he can rely on, and it should be easy to maintain, because obviously the client is someone who is not tech savvy. Basically, I mean, even if they are, who wants to have a product that takes too much maintenance? You would rather go for something that is low maintenance, that can be easily managed by ourselves without any technical help. And then if they probably want it to be built cheaper, they probably want it to be efficient, fast, and they probably want it to be expandable. That means you start with a certain core functionality, and over a period of time, when you expand the business, you want the site to grow with you. You don't want to scrap everything and start afresh. So being that expandability, interoperability, all of these are some factors that the client would want to have in the software. When it comes to the producers, they want it to be easily buildable. So it needs to be technologically easy. It needs to be, testable. It needs to be buildable. So if it is all of those things and some more, of course, then it is, a quality product for the producer. And for the customer, the end user, all the factors that you mentioned when we're talking about, the camera, like for example, taking pictures, or user friendliness, reliable vendor, coming from a reliable vendor. So all of these are factors for the customer itself, and we know that because we are customers ourselves. So you see, there are different factors in a software development environment that are considered to contribute towards the quality of a certain product. Now this is an excerpt from the CST syllabus book. Now all the quality factors, just give it a minute. Yeah, there it is. So it defines that there are 11 quality factors: correctness, reliability, efficiency, integrity, usability, maintainability, testability, flexibility, portability, reusability, and interoperability. Now, all these 11 quality factors are not, desirable factors by all of the three, parties that we have. But for each one of them, it is important for the software to follow, few of these quality standards. But as testers, it is our job to make sure that the software caters to everybody's needs. Now, if you ask me, how do we translate this information that we are seeing here into a practical situation? How do we make sure that when we are testing, we see if the software, for example, is maintainable or not? The chances that we have to implement this practically might be slim, but we always have to, when we are doing a certain job, we always have to have a theoretical reference to what we should be able to achieve. Practically, whether or not it's possible is, dependent on lot of elements that play a role, currently in that situation. But as testers, it is important to understand each of these factors and keep them as a point of reference when you are trying to design your tests, or, put a certain software to test. And this kind of, theoretical foundation can be this is what sets us apart from testers who are trained and, who come with a certain foundational knowledge, and those who are, learning on job. So I'm not going to go over what each one means. So I'll send this PowerPoint presentation out. So most of them are pretty straightforward. So give them a good reading, and if you have any questions, though, feel free to come back to me. Most of them, as I said, is straightforward. So quality simply means that we are building a product that satisfies these factors, and these factors does not necessarily have to be applicable to each of the three stakeholders we have. For example, maintainability is not something, the customer will care about, like the end user. So how you're maintaining the software is none of my business. I only want to use my product, and what you want to do at your end is, not a quality factor as long as the customer or the end user is concerned. But as QAs, if that is a factor that, the client needs to have in the software, then it is our job to test it. So that's one way to look at, how these quality factors might come in handy when we are practically approaching the testing activity. Make sense, team? Great. And one more thing, again, this is not very related, but usually there is always a confusion around scalability. Sorry about the spelling. So have you heard about scalability, and do you have any reference idea, and do you think this is a factor that software needs to satisfy? So scalability, so there isn't a lot that you missed. We were just working on the very first topic, which is the definition of quality. Try and catch up, and if you cannot, just let me know. I'll try to help you. Okay. Now scalability is a factor. Now what is scalability? Let me try and define that. Again, this is not really related to the subject, but I thought I'll just let you know. Now scalability is, yes, those are quantifier for quality. You're right. Scalability is, let's say, for example, you have a weighing machine, okay, and it has a limit of 100 pounds. I mean, that's too less for a weighing machine, but let's say this weighing machine can weigh up to 100 pounds. But do you think it is going to break if you put 120 pounds weight on this? Do you think so, team? No, it will not. And another example is, you probably have, gas mileage. It says that 35 miles per hour, right? And can you say for absolute certainty that after 35 miles, with 1 gallon of gas or something, or, I'm saying this is speed, but if the, gas mileage was 35 miles per gallon, and I put a gallon of gas, do you think at 35 miles it will stop? It will probably take me a mile or two more, given if all the driving conditions are fine, because this is an average. So that additional mile that it gives, that 36th mile that the gas mileage extends itself, that is the scalability factor. Something that can expand beyond its limit without actually breaking or causing anything detrimental. Now, on the other hand, software can never be scalable. Let's say I built a site like Facebook and I expect that there will be 100 users logging in at the same time. So I have built a site that can handle 100 users who will log in at the same time. With the 101 user, this will not work, absolutely not work. Software cannot stretch itself beyond its limit. It has those hard limits you cannot push behind it. So it's not scalable. It is something that will not expand beyond its capabilities. So if there's a database and it has a limit of 500, records or something, you cannot make the software work for 501. Even if it is half or, any fraction more than its limit, the system is not going to be able to handle it. So scalability is more of a factor that is applicable for hardware devices, not for software, not at all. So this is, I know that when in the ISTQB certification exam, you will definitely have one of the scalability as one of the options in, the multiple choice question. So whenever you see scalability and software, there are two things that will not fit in a same sentence ever. All right, so we can move on to the next one, which is the defect. Now this is an easy one. What do you think is a defect, team? Again, brainstorming here. An error, a problem, a bug. Malfunction, shortcoming, unexpected result, and the way program is not supposed to work. Very good. Improper function. So yes, all of those are perfectly good definitions. Usually defect is, any unexpected behavior. So it can be basically any behavior we're talking about. So we'll try and go into the definition much more in detail in a little bit, but let's try to list out the common names that are used to refer to bugs, and all of your pointers are great. So defects are also referred to as issues, bug, problem, fault, um, error. So these are the common names. So unexpected result or malfunction, yes, you could definitely use them, but commonly companies refer to defects with any of these terms. So all of these terms can be used interchangeably. In sometimes some teams are much more comfortable calling their problems as issues. In some teams they call them bugs. In some teams they call them defects. Whichever way you address, it's all the same. Any unexpected behavior is a defect. Now let me try and explain this. Again, defects is an independent topic which we will deal with, for an entire 2-hour or 3-hour period. But to just give you an initial introduction, let's say you have a page like this. And assuming this is a login page, there's a user ID and there's a password. And then there are OK and cancel buttons. Okay, so this is the page. Now when I enter a user ID and password, it is not logging in. Is that a defect? Clearly it's a defect because it's a function that is not working. So if there is a requirement and if the requirement is working incorrectly, that clearly is a defect. Next, if there is a reset button here and your requirements or your document of FRD or BRD or any of these documents, they do not mention the presence of the reset button. So reset button is an extra on your page. Do you think that's a defect? Yes. So it does not matter whether the reset button at that point is working correctly or not, or what's going on. But if there is a requirement and that requirement is deviated in the sense that there is something more than what you expect, even that is a defect. See, defect does not necessarily mean that something is not working. Defect is a way in which testers can bring the focus or the attention of the rest of the team on a certain aspect that's happening on your application. So when you see something, a reset button, probably it's not going to be detrimental to the software. You probably, will tell your business analyst, hey, I'm seeing a reset button here, so what do you want me to do? The business analyst might still, go ahead and say, hey, you know what, reset button, it's not causing any harm, so let's just keep it that way. So the reset button, probably there will not be any action taken on it. But how do we as testers know that that is supposed to be there? So the defect raising is a way of communicating. It is a way of bringing people's attention onto a certain area and figuring out, this is a way of initiating a communication and thought process on something and getting everybody's confirmation. So if you see a requirement that is extra or extraneous or however you want to refer it. So if there is an extra requirement, that is a defect. But on the contrary, if the reset button is supposed to be there and it's not there, that is clearly a defect. So anytime there is a missing requirement, extra requirement, or a requirement that is not working correctly, all these three things will definitely be your defects. Now, in addition to these, there are defects related to the environment. So your database might not work, or your web server might get turned off. So that kind of environment issues, we raise them as defects. So that is, again, we'll see more on environment defects and everything going on. So anything that is causing a roadblock or a potential problem, we always go ahead and raise a defect. So environment problems are a defect. Sometimes documentation errors. The FRD might have a significant problem to it. So in that case, how do we bring everybody's attention? So documentation errors are also defects. Now, in all of these defects, there is a certain special kind of defect that is called the failure. Also, again, these days nobody is asking this kind of basic questions, but a few years back, and sometimes even now, one of the popular interview questions is, what is the difference between a fault and a failure? Now, fault is when a requirement or a certain feature on your application is working incorrectly. Failure is when your whole AUT goes down, and failure usually is accompanied by some sort of restoration activity. So, sometimes you access your sites. Even this happens with our software testing help site also. So sometimes when you try to launch it, it will not come up. There will be a 500 servlet error, or there will be a 404 error. So there is a complete, the system crashes. And when a system crashes and you cannot, do anything about it, that basically is a failure. And failure always needs some sort of, it needs some kind of restorative activity to follow with it to bring the application back to a working condition. So failures, for all intents and purposes, is also a defect, but it is a specialized form of defect which lets, or which immediately communicates that things have stopped and we need to perform some kind of restorative action to bring everything back up and running. So restorative actions can include something like restarting your database, or refreshing your cache and restarting your application. That kind of recovery operations have to follow the failure operation. So defects are basically anything that you want to bring your attention to. So they can be missing requirements, extra requirements, incorrectly working requirements, or they can be environment issues, they can be documentation errors. All good, team, so far? Cool. So that actually finishes our definition part of the class today, which means, thank you, Padma, that's a good question. Fault is any defect, so there is no special definition to fault. AUT stands for application under test. So we will discuss more on why we call it application under test or anything. But the reason why we call it application under test and not say website or anything else is because we test all kinds of applications. We test mobile apps, we test web apps clearly, and we test Windows apps also. So any kind of application that is under test currently, the software that you are testing right now, that's called the AUT, or the application under test. Okay. Um, the next thing is the V model. So let me know if that is still a question, and I'll try and explain that, elaborate that. But that is definitely a part of our vocabulary series going forward. Now, V model is another software development lifecycle model. One problem, again, as a tester, as a tester's fraternity, that we see in the waterfall model is there is no mention, or there is really no emphasis placed on what the testers do and do not do. See, because if you quick recap of what we did yesterday, there is the initiate, define, design, code, test, and deploy. So in this V model, in this waterfall model, the problem was that testing phase does not get mentioned until stage 5. Since we are a QA group and since we are learning QA, we kind of went a little back and we tried to discuss, what happens in the previous stages, how does the testing team parallel with the other phases, developmental phases. That's something that we did. But if you were to read a textbook or something that only discusses the waterfall model, the mention of testing will not be until stage 5. That is clearly a problem. Now that is something that V model tries to solve. V model is a different way, a slightly different representation of a waterfall model that pays special emphasis on the different phases, types of testing, and the different forms of testing that happen in QA. So when you are actually looking at what happens on a project, workflow, day-to-day basis, there is no difference whether the project is following a waterfall or the V model, because practically it's the same. Representation wise it is slightly different, and V model is, I must say that it is extremely useful for testers, because this kind of see, once we understand the V model, we kind of understand how to perform every form of testing. Probably not the technical details, but we kind of, equip ourselves with the foundational knowledge that is required for us to, base our test cases on. And you'll see how in a minute. Before that, Emilio's question is, a programming error becomes a defect until it is discovered by testing? Yes, if it is not uncovered in unit and integration testing, then clearly it has to be addressed in the system testing. Yes. And yes, it is definitely a defect. So defects are defects even if they are identified by developers. So if it's a programming problem and the developer has identified by himself that something's wrong, that still is a defect. All right, V model. So again, as I said, different representation but same core concept. So usually the waterfall model will start with the documentation of the business requirement document, following which there is the functional requirement document. So this here is the define phase. This is the initiate phase. So here you are trying to get the user requirements. You will write them all in the business requirement document, and following which functional requirement documents are generated, and following that there is the technical design document or the technical design phase, and then there is the code phase. So what V model tries to do is it breaks down, it branches out the developmental and the testing activities into two different sides. So that is why it gets the name. So following the code model, the very first type of testing that we do is unit testing. So once the code is all unit tested, next we go and perform the integration testing. The next step is the system testing. And finally, it is the UAT. Now when you look at this, is this any different from the waterfall model or the sequence of steps that we are doing? Not at all. So it is not a different model. It's only a different representation, and it is extremely tester centric. It is for the benefit of testers to let us know the guidelines on how to perform our jobs and to what to base again our testing against. So Padma's question is, in the unit testing, do we need to know basics of programming? If you are going to perform unit testing, then yes. But the chances that functional testers like you and I will perform unit testing is very slim. So probably not. Okay, so coming back to the V model, this is how things are organized. So if you see, it's the exact same thing, different structure. So on the left-hand side, you will see all the developmental activities, and on the right-hand side, there's all the testing activities. And Ditya, I see your question. I'll take that in a little bit. So I have a poorly drawn diagram here. It's pretty much the same thing. Um, Now, on the left-hand side of the V model is all the verification techniques. Now, what do we mean by that? What is verification itself? Now, verification in the sense, it is static testing. Now, we do have a lot of articles on our site that will explain the difference between V and V, which I will send out today after the class. But static testing is where you do not test the product. Now, so let me give you a quick example. When I have the BRD ready, assuming I'm the development and the BA team, and I'll move on to the functional requirement document. So while I'm writing my functional requirement document, my input is clearly my business requirement document. So when I say my input is the business requirement document, what am I going to do here? I'm going to read, understand, and I'm going to transform the content in there from the user perspective to the system perspective. So when I'm saying that, I'm using that as an input, these three things are happening. So in this process, do you think if I wrote something wrong in my BRD, will I be able to uncover that? Yes or no? Definitely yes. So even though the primary activity that I'm performing is right now that I'm consuming my business requirement document. So while I'm doing that, I'm actually, the inbuilt activity that is going on is that I am reviewing my BRD document. So assuming yesterday we discussed a password example, right? So the password rule saying that, no two accounts that the same user holds can have the same password. Let us say for some reason this requirement was incorporated into, so requirement 1 was a part of BRD. So while you're writing the FRD, would you not identify this defect? I mean, would you not identify that this is something that is incorporated incorrectly in there? Now, what is this defect related to? It's related to your final application, AUT, which is the car dealership. Now, how did you know that there is a problem in your car dealership site here? Did we actually test the car dealership site itself? No, because it doesn't exist at this point. But how did we eliminate that defect in the car dealership site? By actually reviewing a document that is representative of uh, the application itself. So right now the BRD is representative of all the business requirements that the AUT is supposed to satisfy. So right now when you are reviewing the BRD for the intent of consuming the document eventually, you're inbuilt performing this activity of review, which is helping us identify the problems on the car dealership site beforehand. But here you're not testing the site itself, you're only reading it. So this is very much static in nature. So static testing is where static testing is also called reviewing or verification. Verification is where you don't actually test the product. You test a document or something that is representative of the product and find if there are any inconsistencies in that. Make sense, team? So let me take one step deeper into the V model, and we'll try and reinforce this concept. So from the BRD we move to the FRD, which means you are reviewing the BRD in this process. And from the FRD we come up with TDD. From the TDD you will review the FRD, which means if there are any problems with your functional document, then you'll identify the TDD in the TDD document. And while you're coding, you'll use all these documents as a reference, which means if there are any problems in all of them, you'll find it. So static testing is, basically follows the process of reviewing and does not necessarily deal with the product itself. So yes, Tina, you're right. It's just reading, or, reading just means that, you're doing it recreationally. So the much appropriate term would be to review, because you're doing a critical analysis of whether or not something is correct. So reading is much too casual. So you would do a sort of a formal review to uncover errors. So this is even though not the main activity or main intention of going through the FRD, this is something, or any of the reference documents, this is something that happens inbuilt. So on the on the left hand side of the V model, all the testing activities that happens are static in nature, and they follow the process of verification. Now let's come to the left hand side. So what do you mean it happens in build? So when I'm doing the BRD to FRD transformation, how do I do this? I'll have to use this as my input. So when I'm using this as my input, I'm reading it, I am understanding it, I'm transforming it. So am I reviewing the BRD solely for the purpose of finding defects? No, I'm actually doing that to use that to create my FRD. So while I'm doing that, this is something that happens in build. Make sense? So it's basically document verification only. Usually, yes, verification usually happens on documents or anything that is representative of the application. So wireframes is, again, it is slightly premature to introduce that concept. So for right now, we can say it does happen on the documents. It also happens on the code actually. See, when the developer writes a code, like few lines of code, they don't, they probably will read the code first to see if this logic makes sense. At this point of time, they probably will not execute this code. They will simply walk through this code, read through this code, and see if if it makes sense, if they think it is structurally, syntactically well built or not. If the developer is trying to figure that out without executing the code and just walking through it for identifying if there are any common errors, that also can be a verification method. So it not just happens on documents. Anything that you don't put to test but you're just taking a look at it is verification. On the other hand, but the development do not correct it, then they might. I mean, why wouldn't they? Because any form of testing is to identify defects. So whether it is verification or validation. So even when you are verifying a document, you're trying to find defects. And when you do find defects, the next step is to take a corrective action. So they will correct it. All right, let's take a look at the right hand side. Now you do have unit testing here. Now unit testing is testing a particular unit of code. Now, as I was telling you earlier, is it enough to just do a walkthrough on this code? Or should this code actually work for me to say that this unit is, completely tested? Do you think the unit has to work? Yes or no? And when it has to work, how do I determine that? I provide an input and check the respective output. For some reason, let's assume this is an addition code. This is a code that performs addition. So it will take variable x, it will take variable y, and then it will do x plus y is equal to z, and probably it will print the result z. So let's say this is the simple code. Now during a walkthrough, I'll just see, am I taking the first variable, second one, am I adding them up, sending them to the third variable, and am I printing this stuff? So this is a simple walkthrough that I would do. Once I finish the walkthrough, the next thing what I would do is I would actually supply these x and y variables and see if the z is printing up or not. If the z is being printed out as an output, only then will I say that this unit of code is working. So verification itself is not enough to test the application in its entirety. But you can say that verification is one of the first steps, a preventive step that we perform, not exactly, it's not complete in itself. So verification and validation, these are two constituent parts to every testing engagement. But unit testing is not complete unless you provide an input, get the output. So here, are you dealing with the actual code itself, or are you dealing with a document that is talking about the code? Which one is it, number 1 or 2? The code itself. So here you're actually dealing with the entity that you're testing. You're working with it hands-on. So anytime you are testing physically testing, executing, interacting with the code via an input and getting the output, that form of testing is validation. So validation is the actual testing itself. And then integration testing is also the same thing. You don't just put the things side next to one another um, and seeing if it's working or not. So they will, they will have to provide an input, make sure it is coming up fine and all that. Now, system is testing is something that, testers like you and I will do. So in the system testing, do you just look at a login page and determine that it will work? No, we actually provide a user ID and password. We click the necessary steps, we click the necessary buttons, and then we actually take a look at the application and see whether it is letting us log in or not. So once it lets you through all those steps, when the application itself works as intended, then you would say that your system test has passed. So that also is, hands-on executing tests on your system. So that is again a validation technique. Same thing is with the UAT. So on the left hand side of the V model is all the verification techniques. On the right hand side is all the validation techniques. So Hini's question is, I'm a little confused about unit testing, whether it is checking code or checking its functionality. It is both. Now why would you check the code just for checking? To see whether or not it works, isn't it? And whether or not it works is its functionality, is the reason why that piece of code exists. So you would do both. And yes, it is something that is done by the developer. We are not involved in it. Team, can you hear me? All right. So Deepthi, I think it's a problem with you. Okay, you're back on. Thank you. So does that make sense, Sohini? It's something that developers will do. So again, this is another thing that we will we talk about in the article in a detailed way. Now, testing, we are always under the assumption that testers only do testing. That is really not true, because on the left hand side, if you see, it is, the developers and the business analysts are the first people who will, use the user requirements or BRD to create an FRD. So there, that verification is happening on the end of the BA and the development team. So it doesn't have to be by us. So even if we are discussing how unit testing is getting done, it doesn't mean we are doing it. Whoever is performing that will follow these guidelines. So that is verification and validation. Again, I don't know if this statement will make things easier or much more tougher for you, but the standard definition, or one standard line that's supposed to demystify the whole V&V concept is that verification is when we are checking if we built the right product. Yes, validation could include verification sometimes. You're right, Tina. That's a good observation. And validation is all about, did we build the product right? So here the focus is, working on the product itself, making sure it's, as per the regulations or as per the requirements and all is validation. But making sure that, a preliminary point of check to see whether or not we built the right product is verification. Make sense, team? Also, V&V important interview question. And not really about interviews, but these are like the building blocks of QA concepts. So it's important to make sure that we understand these before we move any further. So yeah, if there are any more questions, just feel free to let me know. But I'm just going to go back to the V model for one more small concept. So when I am performing the unit testing, or when the developer is performing this unit testing, it is always performed against the code. And when I'm performing the integration testing, this is always against the design. Now, what do I mean by that? Now, to know that unit testing is happening on the code, that is straightforward and simple enough. But why do you think integration testing is happening against the design? The reason why that is true is because I have modules A, B, and C that I built independently, or units of code, and all of them are unit tested and all of them are working fine. Now, when I come to the integration, I'll have to actually put these modules together. I'll have to, when I say put these together, it doesn't mean that I have to place one next to another. I have to make them interact with each other. I'll have to make sure that, they can have a back and forth, integration, communication, all that channels opened up. And we have to test the overall result at the end. So this is what integration testing normally means, that you not just place one module next to another, but you actually make them work with one another. So to do that, you will have to follow a plan. You will have to follow a design. So if you just have to, broadly break this down, if this is your web-based application, so if these are the web pages, module 1 is all about the pages of your site. If module 2 is all your, stored procedures and everything that will help you interact with your database. Now, these two things have to be put together in a strategic, well understood manner, and this information is something that you'll find in your design document. So whenever integration testing is performed, the design document becomes the basis, becomes the point of reference to use and to guide how modules, individual units of code have to be put together. So that is why integration testing is something that is always performed against the detailed design document. And similarly, when it comes to system testing, this is always performed against the system requirements. So because when we are performing the system testing, which is VQAs, we always test the application based on what requirements it is supposed to satisfy. And here the requirements that we are going to take into consideration are the functional requirements or the systems requirements. We are not worried about its technical requirements, or to a certain extent not even the business requirements. For us, if the software is supposed to follow XYZ rules, it is our job to make sure to see if those XYZ rules are being followed or not. Beyond that, we don't. Of course, it is our job to make sure that, if there are any suggestions that we can make to enhance the quality of the product, we are free to do that. But the core competency, or, the core requirement or expectation that is set from a system testing team is to make sure that the functional requirements are all adhered to. So whenever you are doing the system testing, the reference document is your FRD document. And coming to UAT, UAT is performed by the users, we know that, and it is performed against the user requirements. So UAT is not really about whether a menu is working or not, what is happening if I give alphanumeric content in a particular field. So it will not be that basic, because say if there is a payroll site and the company has asked you to build a payroll site, the things that they will be interested in is it calculating the leaves correctly? Is it calculating the taxes correctly? Is it generating the pay stubs correctly? Is it following the statewide rules or not? So all of those core business functionality is what the users are going to be interested in. So they will validate it against your business requirement document. Now this is very important. Again, this I find to be I feel like V model brings a sort of reassurance into what we do. It kind of, makes our job easy, gives us, pointers on where to look for what kind of activities testing activities especially have to happen in what stages. So not only does V model help us understand, the verification and validation and classify where verification goes in and where validation goes in. It also lets us know what kind of testing, the different levels of testing that exist, and what kind of testing has to happen at which phase, against what requirements, what do we use as a reference. All of these topics are very clearly understood with the help of the V model. So any questions, team? So is verification static? Yes. And validation is also called dynamic testing. Thank you for bringing that up. Yes. So that's V model. The next thing, let me erase all the things that I put here. Okay. Now we'll take a much deeper look at all of these different testing phases, and following that we'll do the QA versus QC. So that's all we have on schedule for today. And finally, I'll let you know the assignment for today, and I'll take all your questions. So again, process document. Whenever we create a process document, we'll have to talk about what the input is for this particular step, what the output is, who are the actors, and all the other question words as and when they are applicable. So starting with your unit testing. Now, how often do functional testers do unit testing? I would say mostly never. But since we are the, quality assurance team, or the core testing team, sometimes it is up to us to set some guidelines or standards on how testing has to happen in a project, irrespective of whether it is unit testing or system testing. So at those times, and in those times, it is important to understand how unit testing or integration testing actually happens, even though we might not be practically doing it. So that is why this kind of theoretical knowledge is important to acquire. And also, if you're preparing for any certifications, especially ISTQB, there'll be a lot of questions on unit testing, the different techniques and all that. So that's why we will cover these topics briefly in the class, even though they do not have a lot of practical use value. So the input for a unit testing is an autonomous unit of code is developed and ready to test. So when we say ready to test, it inbuilt means that verification is done already. That means the walkthrough is done. All the problems that can be identified statically have been identified and fixed, and all that is left is that the code has to be validated dynamically. So that's what it means by the unit of code being ready. Now we'll come to the output at the end. The actor says this is done mostly by the developers. And the next one, where, or the environment. So this happens in the development environment. And how does this happen? This usually happens in a manual testing way. However, there are tools to speed up this process. Tools like JUnit, which are used to test like Java unit testing Java code. All those tools are also available, but usually it is manual in nature. So it can be done either manually or in the automated way. Now the output of this stage is a unit of code tested and ready to be integrated based on the design. So we know what happens here. Yes, so there are self-checkers, parsers, all of them are used. You're right. Now, even though, your unit testing, of course, unit testing is quite straightforward. In some companies, unit testing results are shared to the QA team. In some companies, they are not shared. So it's not a general process. So you cannot say that, when you go and when we start working in an organization, we cannot impose our development team to share the results with us. And quite frankly, even when they do share those results with us, it is not extremely useful to the testers, is my personal experience based on that situation. So the output of the unit testing, which obviously will be the defects that they encountered, a list of the defects that they encountered in the process, that may or may not be considered an output for most cases. In some teams they do share it, which is great if they do, but if they don't, that's not going to be a problem to the QA team. But there are certain guidelines that rule or that direct how unit testing has to happen. Now, one rule of thumb that all testers follow at all times, whether they are QAs or developers or anybody else, is 100% test coverage. And you will hear me say this a lot. So what does 100% test coverage mean? Let's say there are 10 requirements that you're supposed to check, and you've only checked like 5 of them. Do you think our testing is complete? No, because no matter how thoroughly you've checked the 5 of them, you've missed the other 5, which means you haven't tested the application entirely. And there might be a bug in those 5 untested requirements that might actually cause a critical crash or a failure, which is never good news. So that is why when we are testing, we should aim for 100% test coverage. If there is a certain requirement, you will have to test it. So following this rule, what are the constituent elements of code? There are code-based statements. I mean, we don't have to understand this, nor do we have to be, experts at coding or anything. Simply, code contains some statements, programmatic statements. It has some conditional statements. It has branches based on loops, and it has decisions, paths. So all of these things are constituent parts. So to achieve this 100% test coverage, unit testing is guided by statement coverage, condition coverage, branch coverage, decision coverage, and path coverage rules. Now what this simply means is, let us say I have a program. This program accepts an input data, and this is something that is keyed in by the user. Okay, so the user keys in a data, and this program puts it in a variable, and then it checks this quickly. If x is greater than, let's say, 0, just for the sake of our example, it executes branch 1 of the code, or else it executes branch 2 of the code, and then it ends, and probably 1 or 2 statements get executed at the end. So statement coverage rule says that if there is a statement in your code, that has to be 100% tested. So you will have to choose your input data that all your statements get invoked. Similarly, condition coverage. So condition coverage means if I'm just checking for x, say 1 value, I'm only checking this or unit testing this code for 1 value, that is 5, x is equal to 5. Now, am I checking what is happening in the else loop? I'm missing that out because I'm choosing only 1 value, only branch 1, or that piece of code, that first piece of code that follows the if statement is all that is going to get executed. So I'm not executing this part of the code, which means it might have errors, it might not have errors. So to make sure that condition coverage is 100% satisfied, you will have to choose 2 values. X is equal to 5 and x is at least 2 values. X is equal to 0 and or a value that is less than 0. So all the statements that are part of your code have to be executed. All the conditions that are part of your code have to be executed. All the branches that are a part of your code have to be executed. All the different paths or decisions. So if you had like a switch statement or a do while statement, so there are more than one condition at that point of time. So different paths, different decisions your code can take. So all of these coverage rules have to be followed. So if there's a statement, and how do we follow these coverage rules? By choosing the right sort of input that needs to go into your testing activity. So this will set some guidelines for the developers on how to perform their testing, and how to get the maximum output out of the unit testing engagement. So there are small problems in the sense small questions, multiple choice questions that have some sort of analytical solution, coming up with analytical solutions in this unit coverage area in your ISTQB, but it's not really a complicated concept per se. Does this make sense, team? So I'm just writing it down so that we all have a reference to go back and check. And next comes integration testing. So the input for integration testing is units of code are tested and ready to be integrated. And then the design document based on which the combinations have to be determined is available. and the output is clearly, the code that is integrated. So we'll talk about, what there are two variations to an integration testing output. We'll talk about that in a little bit. And this is also performed by developers in the same development environment. And integration testing for the most part is manual in nature because it always involves going back to a document and making some decisions over there. So that is why integration testing is predominantly performed by developers following a manual method. Um, Now, when we are talking about integration, do you think it's a white box testing technique or is it a black box testing technique? So, Sohini thinks it's a white box testing technique, but sometimes it's also called a gray box testing technique. So we'll talk about why that is the case. Now, the reason why Manisha's question is, do the developers have to document their testing? That is a good question. Some companies, so you keep hearing, so if you look at the job portals or anything else, you'll hear companies claiming themselves as CMMI level 5 companies or ISO certified companies or companies that follow Six Sigma, all of that. So all those certifications mean that different level of, documentation is being maintained for different companies, and, there's a certain level of process maturity. So some companies that strictly adhere to these standards will make it mandatory for every step in the SDLC to be documented. So in that case, some companies will instruct or will indicate that the developers definitely have to document their unit testing findings and the results and how it went. But sometimes they don't do that. So it could happen both ways. There is no mandate on how it needs to go. But that's a good point. Alright, coming back to integration testing. So I have a module A that needs to, let's say, send some data to module B. Now, when I'm saying this is sending some data, how is this happening? This is also happening via code. Agreed? Now, when I'm saying I'm integrating two pieces of code, I'm actually referring to the process where I'm writing this code. This code is being newly built. So since this has to do with the code and building of the code and understanding and all that, and this is done by the developer, you are looking into the code clearly. That is why it's a white box testing technique. Now, why is it called gray box? That's something we'll come to it at the end. Now, there are few rules that govern, how integration testing can happen. So if you notice in any system, there is a direction of flow of information or data simply. That means A might be sending module A or, unit A might be sending out information to module B. This might be sending out information to module C, so on and so forth. Or it could be the reverse that's happening. So there is a direction to the flow of data. Now, I can integrate in any way I like. I can start with B, I can integrate to C, and then integrate with A. So there is really no rule on how I should do it. So let's say you have 100 modules and you don't know how to integrate them. You will have to have a point of reference, or you will have to have a certain strategy on how to do it. So two strategies that are popular are bottom up and top down. So with the bottom up, you would start with the receiving. The last receiving, module in the, node, you will start with the last one and you'll start building it up. So you will integrate, you'll first pick C, integrate B with it. Now B will become your receiving module and then you will add A to it. So this is your bottom up methodology. It is just a guideline to direct how individual modules can be integrated. So this is one way to follow. Now you could also follow top down, which means you can start with the sending node, move on to the one that it sends to next, and then go with the C. And if you will ask me, is this the only kind of relationship that all modules will have? Will they only have top down? For example, A is sending information to B. Will B not send information to A? In which case both are acting as senders and receivers at the same time. In that case, what? So in that case, it is up to the tester or the developer who is testing this application to pick out how they want to treat a certain module. If they want to treat it as a sender or a receiver, and whether they want to follow a bottom up or a top down approach. But these are two guidelines that integration testers or developers have a choice of choosing from, and implementing it in order to guide their integration process. Now this is a good place where we can try and figure out why it's called a gray box testing technique. Now I have modules A and B. Let's say I'm following the top-down approach and integrating these two. So here I wrote some code. So since I'm still looking at code, this is definitely a gray box testing, white box. And then I'm going into module C. Again, I'm looking at a few pieces of interactive code, which means again it is white box still in nature. But once A, B, C are integrated, I would test considering this entire unit. I would provide an input that will go through A, B, eventually C, and I'm interested in receiving the final output. Now here, am I looking at any code here? I'm probably not. So since this involves some amount of coding, and at the end of the integration testing, when you have the final product, you're not going to look at the inner workings or how the code is being built. So that is why this is called gray box testing. Now let's say I'm still all the modules are integrated, all modules are in part of this. This is still integration testing. I've given an input and provided an output. And let's say I found a defect. Now what do I do? What does the developer do? Do you think they will fix it? Yes or no? They have to fix it. So how do they fix it? By manipulating the code. So in order to manipulate the code, they'll also again have to treat this black box as a white box. So here, since there's shades of black and white all intermixed here, that is why integration testing is sometimes called the gray box testing. There's a slight concept, one more small topic that we will have to talk about in the integration testing, and that is the concept of stubs and drivers. Implementation and use value wise, these concepts don't have a lot, they don't go a long way, but with every field you really have to be equipped with a certain amount of theoretical foundation to be able to build on it. So that is why stubs and drivers is another small topic in the integration testing area that we will touch on it briefly. So in the other example, we talked about how A is sending data to B. So here this is the sender and this is the receiver. So if you have to get a little more technical, this is the calling function and this is the called function. Right? Now, in an ideal world, A and B should be 100% built for us to do some integration testing. So if neither one of them are, if either one of them are not available, then we can definitely not perform the integration testing on A and B together. But we don't live in a perfect world, which means at this point of time, I only have the A. I don't have B. I don't have B ready, but I want to test the integration. I want to see how A invokes B. So at that time, developers can actually make this happen. So what they do is I have A, which is my calling function or the sender, who is 100% built. Now I need B. This one does not exist. So this is a 0% at the level of 0. Now what do I do? How do I make sure that A gets a chance to test the interaction with B? Now let's take a much more understandable example. So this is the view cars. Here let's say there is a list of cars. So from each of these cars you can invoke the by car functionality. So when you can look at a car in, so this is module A, and you can move to module B, which will let you select a car, which will let you buy the car that you've selected in the view cars screen. So let's say this is the functionality. Now in the buy car screen, the very first thing that the user will see, so in the view they will select a car, and when they come here they will be able to view the details of that car, and when they are satisfied they will just click on the buy option. Okay, so let's say this is the functionality. So here it will take you to the payment screen. So buy has multiple pages. But then if I have to test this interaction to see if the car that I selected, the information is getting displayed or not in the buy car, do I need to build this system 100%? No. Just to check the integration wise, it is enough if, I have this functionality built. So what they do is, instead of building the whole module B, they build a small piece of code. This is basically dummy in some cases that will, that has a limited functionality of just making the interaction happen. So in this case, you would just have the view details of the car that is selected in the previous window. Only that functionality is built into your module, which will function as a proxy for your B. So this is called a stub. Now they will integrate the module A, which is 100% ready, with your stub and make sure that the integration wise it's happening fine. Now stub has a limited functionality. It does not have all the code that is constituent of what the module B should have, but it is just enough to make the interaction happen. Make sense, team? Cool. Now, on the contrary, if I have the module A at 0%, so the calling function is not available here, but the called function is available. So this one is 100% available, but I want to test this interaction. The data flow is still A to B. So this is the calling and this is the call function. If the calling function is not available and I make a dummy code that will proxy as my calling function but does have only a limited functionality, then that piece of code is called the driver. Clearly because it drives the interaction to the next one. So that is stub and driver. They are only alternative methods. Ideally, you should integrate with fully functional units of code, but when they are not available, stubs and drivers can take over and help us perform the integration testing and move forward. So these are some techniques that developers use in order to save some time and effort. Okay, so the output of the integration testing ideally at the very end is to have the entire system put together and ready to test. Now I'll just write, so there is the bottom-up approach and then there is the top-down approach. There's also stubs and driver. So are you all with me so far, team? No questions? Okay, so next we'll move on to system testing. This is the area that is, very, very relevant and of extreme importance and interest to us. So system testing is clearly black box because we don't deal anything with the code or, how it is organized, how it is designed, all of that. We are not very concerned with any of those information. The input to this phase is team, just give me 1 second. I'll be right back. Sorry about that. So I'm back. So yeah, we were talking about the system testing. Now system testing, the input to system testing is when, the system, all the units are integrated and it is ready to test in the QA environment. So this is something that happens in the QA environment or the testing environment. We'll talk about the output in a little bit. The actors is the testing team or the QA team. And this can also happen in a manual testing way, I mean, you could do manual testing, like, the techniques that we will talk about in the class going forward, or there's also automation testing possible. Now, system testing, do you think system testing is just functional testing team? Any thoughts on that? And I mean, before we go any further, do you think there's any other form of testing apart from functional testing? Of course there is. Uh, yeah, so let me give you a quick example of, what functional testing means and what non-functional testing means. So let's say there is an application. This is a banking application. So if you are testing the transfers, functionality, first thing is the transfer should go through successfully. That means the operation, the action that the transfer feature is supposed to do, it should be able to do efficiently. So that is the very first point of check, and that is the functional testing, because does the function that this particular action, I mean operation, is supposed to satisfy, is it doing that or not? So that's functional testing. And if the transfer operation is taking like 30 minutes, and if the user is having to just sit there and watch for the screen to come back, do you or do you not think that's a defect? It is a defect. And what kind of defect is it? Where do you think the application is falling short if it is making you wait 30 minutes to tell you if the transfer has happened or not? So this is the kind of defect that affects the performance of the system. Now, functionality-wise, if I have to define a functionality of the transfer application, now how do I define it? A transfer should perform a transfer operation. It should transfer money from one bank account to another. Is that happening or not, even if I'm waiting for 30 minutes? Yes or no? It is. So functionality wise, it is satisfying it. But then there is a defect in the performance wise, in the response time that we are having. So functional wise, it is working. So that is not a functional problem. Performance is a non-functional requirement. So performance, when you're testing for the performance of the application, how is it responding back and forth to you? That is definitely a performance issue. And let's say if your transfers application, it performs the transfer and everything is fine. But it displays some, of course, no bank account would be stupid to do that. But let's say it displays the SSN of, your SSN when you're performing this transfer. But at the same time, it still performs the transfer. The transfer is happening. It's just displaying extra SSN information. Do you think, functionality-wise, it's working fine? What kind of defect do you think this is? This is probably a security sort of a breach, correct? So in the system testing phase, not just functional testing happens. Performance, security, usability, all of these other forms of testing, non-functional forms of testing, also happen in the system testing phase. Now the reason why they happen in the in the system testing phase is because before system testing phase, the application is not there for us to perform any of these forms of testing. So, but one general rule is that in the system testing phase, the very first thing that happens is the functional testing. So all of the other non-functional performance or security or usability testing. So we will define all of these testing types tomorrow. So not to worry if you don't have a concrete idea of what these are. We will discuss them tomorrow. But any of these other things are features that the site good to have sort of feature. See, if it performs faster, it's always better. But if it does not do the initial transfer itself, that's actually like, something that is in your face kind of a problem. So functional testing always precedes any other form of testing, but system testing does not necessarily imply that it is just functional testing. That is something that we have to be very, very clear on. And when we say functional testing happens in stages. So let me tell you what I mean by that. The application is, installed. The usual term that is used is, see, there is a particular code, and this is a certain, X version of code, correct? Version 2.2 or 3.1 or something. So this code is called a build. So build is nothing but an installable, exe sort of a version that developers create. So the build will have that version information, and this gets installed into your QA environment, and this process of installation is called deployment. So usually the way, the jargon or the way in which, this kind of sentences communication is forwarded to QA team is that build 2.2 is deployed to the QA environment. So that's how, it's communicated, even though it just means that the current version of the code is just installed into the QA machine. So are front-end functional defects part of the system test or UAT? Definitely system test. UAT is where, ideally in UAT, there should not be any defects. If there are defects in UAT, it means that the QA team did not do a very good job. So we'll talk more on that later. But front-end functional defects, definitely system testing. So once the build is deployed to the QA environment, this is where the system testing begins. So the very first step to system testing is where we do a smoke test. So smoke test has only two objectives. I'm just going to erase this. So let's coming back one step. Build is installed to QA environment. So this is done. The very first step that happens is the smoke testing. Smoke testing has two goals only. One is, do we have the correct version of the software? And the other thing is, are you able to invoke the application? Are you able to start the application? Is it up and running or not? So this is the most first preliminary form of testing that we do, because let's say if I'm supposed to test on version 2.2 and the installed build is 2.1 or 2, so this is an incorrect version, which means all the tests that you have designed upfront to perform on your application are not going to be applicable on a different version. So the very first checkpoint that we testers place on whether or not we are ready to test is to check if we have the right version of the software installed in the QA environment. So the first step of smoke testing is to see if we have the correct version. The second step to smoke testing is the application up and running? See, if the build is all deployed, but due to some critical problems, if you're not able to, bring up the application, then what is the point of being, we will definitely not be able to test. So there's no point in starting, the testing activity. So if the application is up and running, and if the version is correct, then we move on to the next step. So the next step is sanity testing. So sanity testing is, see, if you see the smoke testing, it is not extremely, it is not exactly validating the application itself, right? We are just checking, is the version correct? Is the application just up and running? We are not really testing the key functionality. That is what we do in the sanity testing. Sanity testing is where we will check for the critical functionality, whether it is working or not. Now the reason why we do this is, let's say I'm checking for, it's a Word application, MS Word application that got installed. So if I have to test this, what are the basic things I should check here? I should be able to create a document. I should be able to save it. I should be able to, insert, copy or paste or do things. So these are the few basic things that I should be able to do. So if these are not working, I will not be able to proceed any further. So let me give you another example. If I'm testing the Gmail application, and in the Gmail, I'll first and foremost should be able to log in. And next I should be able to compose an email, right? So if these are the basic things that are not working, is there anything I can do with Gmail? Not a lot, correct? So for us to say that we are going to perform testing on a build, the critical functionality in the application should not have any bugs that prevent us from going forward. So that is why, following smoke testing, we perform sanity testing. So if you ask me, do we have test cases for sanity testing? How do we know which functionality to test? So the decisions on which functionality to look for is made ahead of time. During all the planning stages that we do, it is made ahead of time. So usually, if, for example, if this current release is about testing Gmail and the Compose, so one of my sanity testing test criteria in that case would be to check if the composing is working fine or not. So it depends on the release, what are we going to include testing in this release, so on and so forth. But it is just making sure that the critical functionality is working fine or not. And coming back to whether or not we use test cases, you could use test cases, or you could just, informally write a checklist and, check things off when they work. Any way is fine. There is no set rule. But it is important that you perform the sanity and smoke kind of testing before we go any further. Otherwise, you would just go into the testing prematurely. So if there is a critical error in a version, then we are waiting for a new build. Yes. Again, I'm not saying it's the optimal situation. Again, it's really not a great thing to happen for anybody, neither for developers nor testers. But if you do find a critical bug, then we do not accept the build and we wait for the new build to come. Yes. The reason why it is a good idea to check upfront is because QA cycles have limited time. So if you see, there is production or development first, following QA or all other kinds of testing, and then it is go live. So any delays that happen in the development team, they creep up into the QA. But if QA has any delays, it will move the go live date, and nobody is happy when the go live date is moved. Usually companies don't move the go live date, which means, see, if I started testing this application day 1 on feature X and this one was working fine, then I move to feature Y and this one is not working at all, which means I'm not able to continue. So at this point of time, I'll have to send the build back and wait again. So which means I'll have to redo module X when it comes back. So this will going into testing prematurely will waste a lot of time than waiting up front and letting them know that it's not working. So yes, but then we do have to wait. Okay, so following the smoke testing and the sanity testing is where you will begin your functional testing. And usually functional testing, it happens in more than one cycle. So I'll explain the concept of cycle in a little bit. Let's say I have 5 new requirements in this application and I have 100 test cases to test this. So I have 100 tests to perform on these 5 requirements. So based on whatever scheduling or all the timing that has been decided earlier, let's say if all of these 100 test cases take 5 days to be run and to test these 5 requirements completely. So usually at the end of these 5 days, do you or do you not think that we will have bugs still open? We would definitely have some defects. Let's say I found 20 defects in these 5 days. Now, my job does not end at, reporting defects. So if they are fixed in the application, I'll have to verify whether or not they're fixed. So that is why in the cycle 1, you would just test these 100 test cases. And in cycle 2, you will repeat testing these 100 test cases, plus you will test the fixes for these 20 defects that you've raised in the previous cycle. Usually companies have at least 3 cycles of testing. There will be cycle 1, cycle 2, cycle 3. So you just repeat testing on the application for 3 cycles, making sure it's error free. But these days, due to things happening very, very fast, 3 cycles have actually gotten down to 2 cycles. So at least 2 cycles are important. 1 cycle of testing is not optimal. At least 2 cycles of testing have to go on. Now, if you're wondering what happens at the end of cycle 2, will there be no more defects and will everything be done? Now, there will never be a defect-free product no matter how many cycles you go through. So there will always be something that needs improvement. There will always be something that needs to be addressed. So defect-free products are a myth and they never exist. But then at the end of cycle 2, all the members in that project team, they usually sit down and they assess the kind of defects that are open. If they are, not so, if they're not so bad, and if they're just, something that can be managed, they will still go ahead and, go ahead with the go live. If they are, serious issues, and if they are very critical, and if they are going to diminish the user experience, so in that case they will actually extend it for one more cycle. So at the end of cycle 2 also there will definitely be defects, but what to do there, about them is a collective decision that is made by the entire project team. So there's smoke testing, sanity testing, and then the functional testing. So a build and a cycle is not exactly the same, right? No, build is the version of the code, and cycle is, testing cycle, cycle 1, cycle 2, and all that. Usually for each cycle you would have a new build, because for cycle 1 the build would be, say version 2.2. Cycle 2 would have bug fixes in, cycle 1. So here the build would be 2.3, the next build. So with each cycle there will be a new build. And when anytime there is a new build, you will have to repeat the smoke and sanity testing always. So whenever, new build is deployed, for whatever reason, it might be a bug fix, it might be a new release, or any other reason whatsoever, smoke and sanity testing have to be done, following which only you'll do the functional testing. Build means version. Build means the code that is, in an installable fashion. So if you're trying to install some software from the CD or from the website, you will get the whole, folder of all the files and setup and all that. That usually is a build. So coming back to here, so yes, this could happen manually the way we are going to learn in the class, or you could go the automation route, which means you would use tools like QTP, Selenium, and all of that. So there's smoke testing, sanity testing, followed by test cycles. In this phase, both functional and non-functional testing, both of them happen. Did we miss anything? So let me know if I missed anything. And then the output of this phase is software that is tested and ready for UAT. So next comes UAT. So is QTP and Selenium, they are automated. They are automation tools. So we'll talk about that. Again, it's again a little premature to go there. And I understand. See, automation can feel like magic when we haven't seen it firsthand. But we will remedy that in the class going forward, but not yet. UAT is a black box testing method, and the input for the UAT is the system tested software. And UAT is validating the system against the business requirements or the user requirements. UAT stands for user acceptance testing, or it is simply sometimes called acceptance testing. This is performed by the client or the end user. So there are two types of testing here. This could either be performed in the QA environment, in which case it's called the alpha testing, or this could be performed in the production environment or the live environment, in which case it will be called the beta testing. So usually UAT is manual in nature, 99.9% of the time, because the end users, they don't care much for more technical stuff, which is automation testing. They would rather just test the application manually and see if it's working or not. And moreover, UAT has a lot to do with not just about functionality, but about the ease of use and how easily are they able to find the options that they're looking for and all that, which clearly the automation tool will not be able to do. So manual testing is a good route to go when we are doing the UAT testing. So one thing that we need to understand in UAT testing, the difference between alpha testing and UAT beta testing is, clearly there is the environment where this kind of testing types happen. But other than that, alpha testing is, specific or in the area of commercial software. Now, what is commercial software? Commercial software is software that is not built for a client, but it is built to act like a product. Now, one example is Microsoft Excel that we're using. Now, nobody has contacted Microsoft and said, hey, I need a software that will let me do the spreadsheet thing. So it is not built to cater to one person. it is built as a package that can be sold as a licensed product that can be used by anybody, right? Another example of the commercial software is the go-to training itself. So neither me nor any other people who are using GoTo Training have actually gone to Citrix and said, hey, we need an online training medium, and they haven't built it tailor-made to me. They have built a product which I'm paying for, getting the license and using. So software that is commercial in nature and that is built to act like a product, when I'm purchasing this software, what would I do? I would take this for a trial. I would put this system on a trial, correct? So while I'm putting this system on a trial, what is it that I intend to check? Um, I will check whether or not, the software satisfies, my need. Is it able to, get me into the meetings? Is it able to get me out of the meetings? Am I able to communicate with my students or not? So all of these are things that I will, uh, normally check. So here, while I'm doing that, I'm not doing it in my environment. So when I'm still deciding whether or not to buy Microsoft Office, do you think we are downloading that? We are not actually. We are going to the site, checking some trials. So we are still doing it at the producer's environment or at the environment where the software is built. So so here again, this is a form of UAT testing because we are evaluating whether or not you want to accept their software. So that is the alpha testing. Alpha testing is usually performed in the environment of people who built the software, and it is mostly applicable for commercial software. On the other hand, if we are talking about beta testing, this is something that happens in the production environment. So beta testing, good examples are all those mobile applications like TalkTone and WhatsApp. They were initially, released to the user. They had their own bugs, but they were still released to the users for trial basis. So there, the users are asked their opinion. Let us know how you feel about it. Is there something you want us to fix? So that is releasing the application into its live environment ahead of time, and at the same time, getting their inputs on it. So that is beta testing. Beta testing is performed by actual end users. And after the testing is done, so the regular, if all the testing is completely done, that is when the product is ready to go live. So that is basically alpha and beta testing. I see that some questions are here, so let me take that. So Amelia's question is, in a commercial software, how are business requirements and functional requirements identified? That's a good question. Now, functional requirements are derived from business requirements. So, but then the question at that time would be, who gives the business requirements, correct? A client should give the business requirements. Now, in the absence of a client, you would actually build a product that will cater to most users. So if we have to take a real world example, so how would you know that when you build a car, there should be a stereo in there? How would you know that when you build a car, it should, have storage space in there? No, none of the car's customers actually told me. But this is the producer's view of how to make a product better. So in that case, the business requirements are not coming from anybody. It's just that they have their own inbuilt team of subject matter experts who have a lot of insights in this product, and it is always a guessing game. So this one might make our product better, this one might make our product better, so they just keep incorporating that. And so once they have some base business requirements to work with, functional requirements are derived from the business requirements. So the next part happens easily. But how are the business requirements identified? Based on the supply chain. So if you think that a certain feature will appeal to your users better, then you would incorporate it. But there is no one client who would do that. No. Clients have its own testers apart from project team. Where do they come? So usually the client's testers who are performing UAT are going to be the real-time users. So for example, if I'm building a banking application that is going to be used by a bank teller or the bank representative, they will become my UAT because they are going to be the real-time users. So they don't have they don't have like testers hired just for testing. For UAT, it will be the real-time users who would, perform the testing. So alpha is when the user is testing in the tester's environment. Yes, perfectly put. So that is about all our testing types. And tomorrow, what I want you all to do is, please bring, we hear all these testing types, correct? So there's recovery testing, there's performance stress testing, load testing, all of these different testing types. Even though we are not going to perform all of these testing types, it is important for us to know what they mean. So tomorrow in the class we will cover a few basic of them, but if there's any other testing type that you want me to define in the class, bring it to the class and tomorrow we'll deal with it. But again, I don't claim to be a know-it-all. There might be some testing types that I don't know either, so we'll learn together. Yeah, so that finishes our V model and the different testing types. And the next thing that we have on our list is the difference between QA and QC. So once we discuss this, I'll let you know the assignment and we should be good to go. Just give me a second. Okay, my digital pen decided to not work, so I'm just going to use the keyboard. Okay, so QA stands for quality assurance and QC stands for quality control. So quality control is simply finding defects and taking corrective action. Now, when you are saying that you're finding defects and taking corrective action, the inbuilt understanding is that the defect has already happened. So the primary activity that we are focusing right now when we are performing the quality control operations is to find the problems that have already occurred. So this is defect identification. And of course fixing eventually. Since testers don't do the fixing, it's just confined to the defect identification. On the other hand, quality assurance is all about defect or detection, yes. Defect prevention. So when we say defect prevention, how are we preventing defects? The one way in which QA teams prevent defects is by establishing processes. So we are talking about unit testing, integration testing, so on and so forth. Now, why are we learning that? We are doing that just because, in case unit testing is happening in your team, you can actually lay some guidelines and say, hey, this is, you can document your results this way. If the developer is interested in writing test cases, you can let them know how to do that. Why are we doing all that? To actually bring in a level of accountability and, to bring in maturity into the process so we can rely on it. And also, testing does not come until the 5th stage in the waterfall model. But why are we involved right from stage 2? That's because we are, performing the verification activities and making sure that defects don't happen. We are actually, understanding what it means to say that the quality, to actually assure the quality of a certain product. So our job is not just defect detection. We do defect prevention, and quality assurance includes QC also. So when we call ourselves the quality assurance team, we are involved from the beginning. We not just test, but we create processes that will streamline the entire process. And eventually we'll also do defect detection, because no matter how much you prevent, there will still be 1 or 2 cases where defects or problems do happen. So in that case, we will also do defect identification. So to call ourselves, quality control engineers or just software testers or even manual testers is like shortchanging ourselves, because what we are doing is not just finding defects after they happen, but when we are involved in the entire process, understanding the system and working with it to make sure that it is at its best, as much as we can help it. So are there in different environments? No, actually there are 2 different processes. So if they're hiring you just to come in at the end and identify problems, it's an already built application. You're just told to find defects and report. Then you're performing the quality control operation there, because finding defects means that those defects have already happened. So you'll just identify the defects. But if you are in the process involved from the beginning, if you are in a project, where you have been on the team from the defined phase itself, understanding everything, creating your own review processes and all that, then you are performing the quality assurance role. Quality assurance, as I said, also includes testing. Quality control is simply testing. Quality assurance is developing the processes around testing that will give a better enhanced result. So we always, that's why, call ourselves the quality QA team, not the testing team only, because that is very limited in what we do. And also it gives a very one-dimensional feel to, our role in the IT project. So that's the difference between QA and QC. And assignment for today, let me write a sample assignment. So today we will identify, yesterday was when you all listed out the functions of the application. So if the function of the application that you listed out was gmail.com's compose email. So if the function that you've listed out was something like that, like this, the user should be able to compose and send an email. I mean, it's pretty straightforward. Now in this feature, what is it that you would test? So I would want you to list out all the features. So all the different conditions that I would put this particular feature to test to. So I would test if the compose email can send email with no content or body. Then I would check if the compose email can send email with no subject. So what happens if I send email with no recipients? So am I able to compose email and send it with bulky attachments? Lots of attachments. Different formats of attachments. So these are few things that you would test, correct? So I'll compose email and then cancel and not send. So is it getting cancelled or is it getting saved? Or I might want to just compose email and save it in the draft. So you get the picture, correct? So each feature has multiple conditions that you can put it to test to. So go ahead and write what you would test in each of these features. So try to do this for at least 3 of your features. So if you want to use the features that you've listed out yesterday in your assignment, feel free to do that. Or if you want to start fresh, new application, new features, new what to test, you can do that as well. I'll leave the choice to you. So try to do this for at least 3. If you can do more, that's great, but at least 3. And don't think about what is the result, whether or not it is successful or not. So for example, compose email with no recipients is not going to be successful because you should at least have one person who you are intending to send this to, one email ID at least. So in that case, it's not going to be successful. But that doesn't mean I'm not going to test that. I'll still have to test it. So think about what are the aspects that you would test in each of these functions and try to list that out. So it does look straightforward, but there is a lot of learning curve in this assignment. So try and do this in each one of your way, how you interpret it. And tomorrow when we come back in the class, we'll see if there are any shortfalls and we'll see if we have to, approach with the different strategy or anything. So that's all I have planned for today's class team. So I'll open up the forum for any questions that you might have, and tomorrow we are going to discuss the agile model. I know that we are yet to discuss the shortfalls of the waterfall model, but we'll do that tomorrow because that will be a more suitable stage where we can actually do a comparative analysis. So tomorrow is agile, different testing types, and an introduction to the live project. So what is the most widely used model? That is Sohini. Yes, you actually asked this question before, or somebody else did. Sorry about not taking that at that point of time. So the usage of the model, which model is widely used, is not actually dependent on what a person likes or what a company prefers. None of that. It is basically based around what kind of business we are dealing with. So we'll discuss more on this later, but there is no answer to which one is most widely used. But a recent study in the market actually has shown that 85% of the projects are moving from the traditional waterfall model to the agile model. So I would say in the current market stage, agile is the most popular model. Um, but having said that, I'm a firm believer in the concept that no matter which shape these developmental models take, there's always a waterfall model at its core. And we'll do that tomorrow. Okay? Is it time-based as well? Absolutely. Time is money. So again, following tomorrow, I mean, of course, we'll talk about this. But if you have a smartphone on which you have some applications, once in a few weeks at least they will tell you that the new update is available. So every time there's an update is available, that's actually a small project happening at that application vendor side, and that project is, if you notice carefully, there's at least one every 2 weeks, if not sooner. So that's how quickly applications are undergoing changes, and that's how quickly these software development models have to deliver the product. So yes, absolutely they are time-based. How many test cases is required for each feature? Are you asking me about the assignment? There's no limit, as many as you can think about. And that is true of the real-time scenario also. There's normally no limit on how many tests you can perform on an application. So as many as you can. Anything else, team? So 100% test coverage simply means that if there is a requirement on your application or if there is a line in your code, you will have to test it. So how do you make sure that a particular line in your code is tested? By providing the correct data. And when we move on to much more system testing phases, you'll see that 100% test coverage is, of course, it's applicable for unit testers and integration testers. It is applicable to us system testers in terms of making sure all requirements are covered in test scenarios and all test scenarios are covered in test cases. Again, it is slightly premature to go in there, but the concept of 100% test coverage is a guideline that tells us that if a certain feature exists in your application, then you will have to 100% test it. Otherwise, the testing is not complete, not effective, because the one that isn't tested, I mean, the ones that you have tested might be really good, but the ones that you haven't tested might be really, really bad. So, all right, team, I'll send out the PowerPoint presentation for today. Again, there's not much, just for your reference on the quality factors, and then I will send out, the V model is poorly drawn, so I will not even, but I'll just attach it all the same just in case you would want to take a look at that. And then I'll attach today's notes in the email. Yes, the link to your class is valid indefinitely. But if you have any problems accessing the link, sometimes we do, because sometimes GoToTraining also comes up with a new release, and then we will have issues with that. So if we do have issues like that, then the best person to contact is our administrator, Vijay. Okay, so I wouldn't have access to all of that, but they should work indefinitely. All right, then. Thank you, everyone. Thank you for joining in. I will see you all tomorrow. Do not forget to bring in the different testing types that you want me to define. And I will see you all tomorrow. Have a good one, team. Thanks, everyone. Bye-bye.